So hi and welcome everybody. Welcome back to the second part of the lecture. In the first part, we talked about the content of the course, the main topics we are going to cover, the wireless technologies, wireless devices, the application, the importance of wireless security, and we explained why we need wireless security. And I hope I was able to convince you enough of the importance and significance and the criticality of having robust security mechanism in wireless networks. Now, having talked about wireless, we need to compare wireless networks to wired so that we can understand the differences in their security. Now, the main differences between wired and wireless is the fact that wireless is open to the medium, that your signal goes into the air, while wired, the signal is confined within a cable, within the medium. That's actually the cable itself, whether it's copper or fiber or any material. Due to this critical reason, wireless needs more security than wired, because your signal in the air, anybody can listen to the signal, anybody can jam the signal, and we need effective mechanism that can overcome these problems. And in the table below, as you can see on your right-hand side, you have this simple picture that shows you the difference between wireless and wired. That in wireless, you don't need any cable, and wired, you always need to be connected with a cable. And on the left-hand side, we show you the differences between wired and wireless in terms of different parameters, including mobility, reliability, interference, environment constraints, connection speed, support, switch port, and cost. Most of them are intuitive. Anybody can understand the key differences between them. But the key thing here is to understand that wired networks are more secure than wireless. And this requires that we develop and work more on the security of wireless networks, because they are open to the air, and we need to come up with reliable, robust, and resilient approaches that can ensure the security even when the signal in the air and being exposed and being accessed from different users or within the range of different users in the network. And as is the case with man in the middle, as is the case with wired networks, wireless networks also exposed to malicious attacks, including eavesdropping, denial of service, jamming, spoofing attack, and man in the middle, and message falsification, message injection, modification, and some other ones we will talk about in more depth in the coming slides. So here we show we continue talking about the differences between wired and wireless, and more importantly, we just explained to you that if we were to summarize this briefly, we can draw these two circles. We could draw these two circles where we put wired attacks at the left side and wireless at the right side, and there are some common attacks between them. We said that these common attacks belong to the layers. Belong to the layers which are to these layers. Common attacks are associated with these layers: application, transport, network. When I say application, I mean application representation session, transport, and network. So the common attacks for wireless and wireless are these layers. Wired attacks related to PHY and MAC is different from the wireless attack related to PHY and MAC, because the structure of the MAC here is different from the structure of the MAC in wireless, and the structure of the MAC in wired is different from the structure of the MAC in physical layer in wireless networks. And due to these reasons, wireless has unique properties, unique features that make it a little bit completely more challenging than wired. So in a more explanatory figure, you can have a look at this figure, and you can see that we have network, transport, application. They have the same things. And I just explained maybe in the first part where I said if you have you have SQL injection or application security at a WordPress level or a website level or an iOS level or Android level. They are applicable everywhere, whether wired or wireless. If you have port security level, it's the same. SSL, HTTPS, they are the same. Network, IP security, they are the same for both wired and wireless. What's different is when you go to the Mac and PHY. Mac regulate the access of the users to the resources of the network. And Mac, this is the functionality of the Mac. In wired is different than wired, although they have the same goal, but they are being implemented using different protocols and different methods. For example, in wireless, we have the carrier sense multiple access collision avoidance in Wi-Fi, and we have the OFDM multiple access in 4G, where in wired, we don't have such things. We have frame relay, point-to-point communication, point-to-point protocol, frame relay protocol, address packet routing, those are the protocols that are being used at the Mac layer in wired. They are completely different from wireless because the nature of the medium is different. And this shows you a clear message that the medium, the nature of the communication environments dictates you what types of Mac approaches, Mac protocols, Mac techniques you can use to serve the user. Physical, of course, is different. The main key difference that in wireless you have always antenna that's interfacing the air, so that you can convert the antenna converts the electrical signal to an electromagnetic signal being spread in the air until it reaches the receiver. Well, whereas in wireless, in wired networks, you don't have such a thing. You don't have something called antennas. You have cables, you have confined and bounded media. So due to these things, the security requirements are different, and the security requirements are the same, but the security mechanism should be different, and more emphasis and more work and more techniques should be implemented for the wireless network so that it can make it secure in the same level of wired networks. So this was the key taking of this slide. And if we move on and explain having talked about the OSI layers, we need to understand quickly their functionalities. First, before we get into their functionalities, for those of you who don't want to forget their names and their order is very important. For example, physical layer, we call it layer number 1. Data layer, layer 2, or data link or Mac layer, we call it layer 2. Network layer 3, transport layer 4, session layer 5, presentation layer 6, application layer 7. If you want to memorize them in order and don't forget them in the future, you just have this phrase that you can always remember it. All people sleeping through networking don't pass. So the first letter in all represents application, people, presentation, sleeping, S represents session, through represents transport, networking represents network, don't, data link, pass, physical. And you have this in the transmitter and receiver, the sender and the receiver, the sender and the sendees. So the in the sender you have the data come from application, which is layer number 7, to the physical layer, which is layer number 1. Whereas in the receiver, the data goes from, it's not actually data, it will be signal. It goes from layer 1, the physical, up until you reach the layer number 7, which is the application. And at the application layer, your data is basically at the application layer. Let's say your data is media. Give me examples of media, just 4 or 5 examples. Let's together give the
picture.
The data. Yes. So here we have medium. Let's just see what can we do here. Yes, you can. Do you have any question? You want to ask something? Anybody? Any questions? No questions. The slides are working. You can see them. Everything is super nice, super awesome. Yes?
Everything is fine.
Very great, very great. Then if you can see the slides, then that's wonderful. What I was saying that at the application layer, your data is basically different types of media. Let's say you have text, you have image, you have video, you have audio, and you have different types of data based on the application that it generates. Like for example, when you have executable files, you have PDF files, docs files, you have based on the application. Each application has its own media extension. So the data here is kind of media, and then in the presentation layer, you translate this media into formats that the computer can understand. So you use the ASCII code here to translate your data, which is written in a human language. You can understand it, read it, or see it, or visualize it, to something like ASCII code. And this ASCII code uses the hexadecimal, and then it converts it gets converted to bits. You then encrypt them. So the encryption is basically, most of the time, the end-to-end encryption is happening here at the application layer, application and transport somehow together. And you compress the data because you want to get rid of the redundant data that's not providing any information. You want to compress your data using source coding methods, so that when you come to transmit your data through the air, you utilize minimal bandwidth, because the bandwidth, as you know, is very costly. If you took wireless communication course with me, we talked about how expensive the bandwidth is, and that companies buy the bandwidth from the government and pay millions of dollars to get 20 megahertz bandwidth to use it for transmission to the users in the wireless networks. And this is very, very expensive resource. That's why we have to use it properly and efficiently. Otherwise, we will be wasting our money and our resources, and the company will not be able to generate enough revenue, and then they will not be able to hire a large number of employees and people, and then people will start complaining about jobs and unemployment, and things will get messy. So it's very important to see this simple problem, technical problem, can lead to social problems. So it's very critical that you utilize the resources very effectively, very efficiently, so that you can keep the system operating within an acceptable, affordable cost. And then everybody hopefully feel happy, and then things will run smoothly. Then when you go to the session is responsible for establishing, managing, and terminating the connection between the transmitter and receiver using APIs, socket, WinSock. For example, when you talk about Webrtc, Webrtc, this protocol that produced by Google to enable communication, fast reliable, low latency communication through the internet, through the web browser. I mean, you have many applications where you can have an audio and video call from your within web browser, like the way we are doing right now. I'm talking now from the web browser. So what protocol that assists this? It's the Webrtc, which is kind of responsible for establishing the session quickly, reliably, with low latency and less overhead and less handshaking. So then we go to the transport here, the heart of the OSI layer, the transport. And the goal of the transport is to provide reliable process to process message delivery and error delivery. And this is so critical, and one of the important functionalities of the OSI layer. And the way we have two types here. We have UDP and TCP/IP. The UDP, if we were to classify them, we have the UDP here, and we have the TCP. TCP is connection oriented. Before you start communicating with the device you want to reach, you need to establish a session, handshake with the receiver, send ACK, NACK, agree that the connection is ready, the resource is available. Let's get started. Let's start talking. And this is connection oriented. In UDP, user data protocol, the connection is not oriented. We call it connectionless. You don't need to establish these handshaking procedures. You don't need to go through these handshaking procedures. And the reason for that is because the data, the type of applications that we use in UDP are delay sensitive. Example of these applications are voice communication, video communication, gaming. Those applications are extremely sensitive to delay. And there is no time to shake hands with the receiver and exchange messages to allow us to send. We have data, we want to send it quickly. And however, the data here in TCP is more reliable, where in UDP the data is not that reliable because you don't retransmit whatever you miss. If you transmit a packet and that packet is not received by the source correctly, then the source will not ask again. If you send a packet to the destination and destination does not receive the packet successfully, he cannot ask for a retransmission of the packet. He just drops it. Whereas in TCP, you have the opportunity to ask one more time for the missed packet. And that's why TCP is very good for which kind of applications? It's very good for file transfer. For example, if you have this experience where you are downloading a file or uploading a file, it downloads. If the process is not 100% complete, your file will be corrupted. You will not be open. You will not be able to make use of it. So it has to be fully 100% complete. If, for example, in Pakistan, you might download the file within, let's say, 10 seconds. Here, you might download the file within 15 seconds. It does not matter the time. The most important critical thing that you send it reliably. But in UDP, no, time matters. Time is important. I don't care. Within this time, I want this data to pass through this destination node, to go there. So TCP is good for file transfer, for email transfer, for message, for text, for the web browsing. Have you ever seen a situation where you request a website page and you don't get the data reliable? I mean, you get half of the data. Some of the words are seen, some of them are not seen. Some of the images are appearing, some of them don't. Not really. You have to get the whole page. But what's the catch here? Some websites are fast, very fast. They have very quick response. less delay. They can deliver the page very quickly, and some other websites are slow. But regardless of that, both of them provide you with a reliable data. So this type of question you might see in the exam maybe. So UDP is connectionless, is fast. TCP connection oriented. TCP does not care about delay. Most important is reliability. UDP cares more about delay. Reliability not that important. So UDP is good for voice, for audio, for video communication, for gaming. Those are very sensitive to delay, where TCP is good for texting, messaging, file transfer, web browsing, HTTP, HTTPS, and some other similar protocols. And therefore, TCP, they have this capability of organizing and reordering the packets, because the packets of your data might not reach the destination in order. So they have this opportunity of reorganizing and reordering the packets in such a way that they are in sequence, in a logical sequence. But in UDP, we don't have this thing. A TCP has the opportunity to ask for a retransmission if the packet was not received successfully. UDP does not have that feature. And therefore, we call this the heart of the OSI layer. I talked a little bit too much about it compared to the other layers, but this is the heart. This is the key. This is the core of this model. Now, then we move on to the network layer, which the main responsibility of network layer is to route and move packets from source to destination effectively with certain limitation and certain requirements, like minimal path, minimum latency, minimum resources, minimum storage, minimum power consumption. You can based on your requirements, you can end up having like a bunch of routing protocols. The most important thing is to make sure that you meet the requirements and the demands of your network to provide internetwork. In data link, you organize your bits into frames and you add some headers. The MAC network, it's IP network. In data link deals with MAC, and you organize the bits into frame, and then you provide delivery within the local network at your home in the wireless or wired network. The physical layer is the most complex and most confidential layer that the information on the physical layer is not shared on the internet, unfortunately, and there are little number of companies holding this information, and they don't share it with anybody, and nobody on earth knows how to do a physical layer structure for a wireless device, except bunch of companies around the world. So this is secret, confidential knowledge. They don't share it on the internet. You don't even read about it. You don't know how to do this. An example of this, if I ask a country like any country, like I want companies that can produce and develop a physical layer for a wireless device, like NIC card. I want to produce NIC card. There are countries, they don't have such companies to do this. Only few companies, let's say there are few companies in the world that do this and keep selling these things to the rest of the world. So physical is very confidential, secret. The information is not shared publicly on the internet because of secret trades. They don't want anybody to compete with them. And mainly my field in physical layer, and I have been studying physical. But what we are studying from books, and those books are published online. And honestly, those books, they don't teach how they don't teach you how to really build and understand and answer all the questions in your head about what's going on in the physical layer. They teach you just like the things they want to teach you. They don't tell you the secrets of how to really develop a physical layer from A to Z. So it deals with signals, the physical layer. It deals with signal. It takes your data and converts it to an electrical signal, which you then process it, you modulate it, you encode it, you manipulate it, you filter it, you apply windowing to it, you amplify it, you send it to the antenna spread it to the air, the antenna convert the signal into an electromagnetic wave that propagates through the air. It's like nobody knows what's going there, except few people, few companies in the world. Trust me, I'm in that field. Very few. The information that enables you to build such a thing, they hide it from you. And we need to fight for this and keep pushing until we know how this here hidden information. Really, till now it's hidden. So this is the most precious, the most effective, and the most confidential layer ever. So those things you will find plenty of information here. Everybody in the world is working here. The application layer is the most profitable layer ever. So you build this once, but here you infinitely keep developing applications and websites and whatever, whether desktop application, mobile application, Android application, iOS application, gaming, whatever. It's infinity here. That's why everybody, the developers, everybody is here. Everybody. You just need C#, C++, C, Java, Python, Android, whatever, PHP, and you can do magic here. Of course, you will not be able to build complex applications if you are weak in math, if you are not strong. You just develop basic applications, basic Android apps, showing the news, showing simple functionalities, login, exit, outlook. So it's really, if you want here, everybody's here. It's very profitable. The whole world is here. Facebook app, WhatsApp, all these applications are here. This is the most confidential, most secret physical layer. It affects everything about it, above this layer, but only companies like Ericsson, Nokia, Huawei, even Google does not know how physical layer work. It does not have the capability to produce physical layer. Even like recently, Apple, they got to know how to make chips. If you have heard, they produced a new chip for the MacBook. So that chip is basically the physical layer that have the functionality of communicating and transmitting. And all these are, there is information and knowledge available on the literature about this. But like, you decide where you want to be expert. So, and all of them, you have demand on them, whether networking or Mac layer or physical or application, whatever. My field is mostly related to these two layers as a wireless security expert, as a wireless communication researcher, wireless security researcher. I am mostly concerned with these. Although I work here, I'm working here as well. Everybody works here. But where are my expertise here? And why I'm telling you the information is confidential, because all the books we see are not valuable enough to make you able to build your own chips and your own devices that can communicate. And if you ever want to be secure, why I'm talking this, why I'm speaking about this, why I'm mentioning this, why I'm emphasizing it and somehow exaggerating, because if you don't know what's going on here, you can never be sure of whether you are secure or not. And if you want to be secure, you have to build your own device from A to Z. Yes, if you want to make sure that you are having absolute security and nobody can hack you, you cannot buy this device from any country, any company in the world at all. You have to build it by your hand, by your country, because nobody knows what they did, what they made. So unless you do it yourself, then you can be sure. So that's why common advice to all people out there who want to be secure. You cannot be secure if you are using other people's applications and other people's products and services and physical layer and data link. You cannot at all. That's why it's a matter of independency. You can become independent and ultimately secure if you understand how to build this stack from A to Z. From A to Z, you need to be expert in this. So here we talked about this, and we said that this is software upper layer. They are software based. Here we have hardware based, and here you have the heart of the OSI layer. Hardware based because here network, it deals with routers, data links deal with switches, physical deals with antennas, hubs, and the chips and DSP processor, and the ASIC and those types of components. So that's it for this slide. I think you got an exposure of what are the functionalities and responsibilities of each layer and the importance of them and how they relate to security. So having talked about this, we can now understand, before we move on to the security of these layers, we just want to give you example of protocols that are happening at these layers from the application to the physical. So for example, the application deals with the protocols like you have the SMTP, which is the Simple Mail Transfer Protocol. This is the protocol used for sending and transmitting bulk emails or normal emails, but usually they use this service for marketing purposes and for sending like thousands of emails, millions of emails at once. You have HTTP, Hypertext Transfer Protocol, which is used in web browsers, and you have the HTTPS. HTTPS is nothing than HTTP, but that uses SSL and TLS, secure socket link or transport layer security. And you have the file transfer protocol, which is responsible for transferring your files. You have the POP, Post Office Protocol 3, which is responsible for receiving your emails, not sending them. And you have the Simple Network Management Protocol. This is for managing issue at the application level. It shows you statistics and how much resources are being consumed by each application and this and that. So when we go to the presentation, which is responsible basically for translating your data, your medium, it translates your media produced content into a language that the machine can understand, like ASIC and into bits. After that, it uses encryption. Encryption here, we mean by encryption, like you use here RSA encryption, DSA hashing, and ECS elliptic, complex encryption, these types of encryption, and then you compress your data. Those are the main one is SSL, which is the one you use. SSL is the one is a certificate issued by certain companies to your website or server, and then anybody on your any user that come into your website, any user that comes into your website and wants to use it, and for example buy something or send a message or request some information, all the search activities, all the information being entered, all these things are going to be encrypted using advanced encryption algorithm like RSA or ECC or post hashing mechanism, and being sent to the server via an encrypted channel end to end, and then the server requests back. So basically, for example, if you visit this website, let's say we have this website.
Excuse me, I think the video is stuck again. Stream.
Start again. We are on the Osi Layers functionalities and the protocol. Do you see that?
We're at Osi Layers functionalities. We're at slide
and
number
the
7. No.
Slide number 7. I'm on slide number 8, like talking about the functionalities and the...
Yeah, it's stuck.
Now, do you see it?
Nope.
That's okay. Okay. Do you see if I go to other website, for example, I'm here typing a new website.
No,
Professor. Do you see? No.
No, sir, the slide will be stuck.
Okay. Again, the slide stuck. We can stop here then, guys. Thank you.